Good morning, everyone. I'm honoured to be the first speaker in 2025. For those who may have attended or remember, my last webinar, I think, probably would have been on the eHealth 1 specification, which was the previous Content Information Type Specification I created. Yeah, very pleased to be back again with a new CITS, this time for 3D product model data. So the agenda today, I'll give a brief introduction, and I'm sure there are many of you who are familiar with the e-archiving specifications, but it is useful to provide some context for the new work and as to where that fits into the e-archiving specification structure. And then we'll move quickly on to talk about the specific new content information type specification for 3D product model data, so-called 3D PM. And then we'll dive into the specific requirements. So really the down to the detail of, okay, so how does this layer onto the existing specifications and what are the actual requirements? A bit about next steps, because as always with the specifications, they are a long-term project, and there will be next steps in terms of the maintenance and refinement and feedback process. And then we'll, I think, have plenty of time for a question and answer session at the end. So just a quick review on the e-archiving specifications. So e-archiving specifications are a structure, a hierarchical structure, consisting of the common specification, the CSIP that you can see at the top of the chart here, at their base, and then with other documents or specifications layered on them. It's structured in this way in different parts and different documents because it allows us to be very flexible and not to have to issue very large and difficult to maintain documents concerning specific areas. So the common specification at the top here is the most important document, and that sets out the requirements for any information package. And that can be for any data type. And in fact, you can build a package according to the common specification, and you can validate that using the E-ARK tools. And that is a perfectly valid way of creating an archive and being conformant to the archiving specifications. But we do go further than that, and we do provide specific information and requirements to actually create packages as defined within the Open Archival Information Systems, so namely the submission package, the archival package, and the dissemination package, so you can actually discriminate between these package types. Well, we provide some overlay information as to how you would add archival information, so archival metadata, and that, of course, is common to all archival packages, and similarly, preservation metadata, which is common to all packages. And then we come to the content information type specifications, which we are talking about one of those today. And those concern either specific data types and or specific domains. And they're adding requirements, so they will add to the requirements as set out in the CSIP and in the package specifications, and those requirements will be specifically concerning the data type or the domain that we are dealing with. So for example, we have an existing CITS CIARD, which is a CITS related to relational database systems and the archiving of relational database data. We've got a CITS for electronic record management systems, the ERMS. We have a CITS for geophysical data. The eHealth 1, which concerns patient medical records, which is one that I created about 3 years ago. The eHealth 2 concerning cancer registry data, and so on. And the CITS 3D PM is the latest new CITS to be published, which was a commitment within the current procurement period. And I'll describe on the next steps and how we're going forward as to how that work will continue. So CITS 3D PM was published on 15th of December last year, and is the latest in this line of content information type specifications. So the layered data model means that all conformant information packages according to the e-archiving specifications conform to the common IP. They will be configured to be a package according to their role. There will be a submission package, or there will be a archival package or a dissemination package, and they may, but don't have to, may conform to specific content information types. So the CITS are there to be used, particularly for data types like relational databases. They're very much required to transmit that kind of information. And they are available for users who want to deal with specific data types like eHealth or within data models. So they deal with a business-specific area, with a domain, or with a particular data type. And with 3DPM, we've added to that kind of layered approach in that there exists already an international standard for long-term archiving and retrieval of product model data called LOTAR. LOTAR is also published as EN 9300 series, which is also the NAS 9300 series in the USA. And LOTAR describes a lot of the processes and management requirements for the long-term archive of product model data. LOTAR references quite heavily upon STEP, that is the open exchange standard for product model data. It's ISO 10303, and it heavily references on OAIS. So we have a very common foundation between the E-ARK specifications very much being based on OAIS, and the LOTAR specifications being based on OAIS. So a good sort of foundation point. The specifications are published by the DILCIS Board. So this is an independent governance board, which is hosted by the DLM forum. And you can go to the DILCIS Board website, which I've shown here, dilcis.eu, and I imagine that Jamie will put that link into the chat. And there you can get hold of the documents and the supporting schemas. And there is a lot of information there on events, so on public reviews, on new publications, and other events which are driven by the DILCIS Board. But you can also go to the DILCIS Board GitHub. So we actually use GitHub as the primary repository for the specification information. You can see here the various repositories. So there is the CSIP at the top left, and you can see the CITS 3DPM at the bottom there. And within those repositories, you can actually get hold of the documents. You can get hold of the METS profiles. There are some vocabularies, and in some cases there are some examples, as there is in the CITS 3DPM, that you can look at, so package examples. That is the main way of feeding back. So for each repository there is an issues tab. You can go to the issues tab and you can raise an issue if you want to provide some feedback, or you've actually spotted a problem. And the issues are then dealt with by the owners. So I will deal with all of the issues raised by the CITS 3DPM, and we'll report back through GitHub on progress and when that is likely to be fixed. So we then fix in a series of revisions. We're on 1.0.0 on CITS 3DPM. I've already got a branch actually on the repository, which you'll probably be able to see, which is 1.0.1. So that's already addressing minor issues that I've found myself. So the CSIP, the Common Specification, what is the purpose of that? So it's to achieve a common understanding of the requirements which need to be met to achieve interoperability of information packages. And I want to stress the word interoperability, because this really is what the E-ARK specifications and the whole initiative is about. We are based very heavily on the Open Archival Information System reference architecture. So that's OAIS, which is ISO 14721. OAIS is very widely adopted and understood within the domain, but it is not specific in terms of implementation. So OAIS very clearly sets out a recommendation to store data in information packages, but it does not actually describe the physical makeup and the requirements and the metadata included within those packages. So there is another layer required on top to actually achieve a level of interoperability such that the packages which are created according to OIS can then be exchanged and understood by different users. So the eArchiving specifications layer on OIS, and they provide that necessary detail and texture to give us a basis for very much interoperable information packages. Of course, that means that we can have information packages submitted to us for externally to our archive. We can disseminate information in an interoperable format, but also, of course, we can actually have an archive ourselves, which is mobile in terms of the software platform. So whatever information, ever system you're using today, if it's E-ARK compatible and you change that for another E-ARK compatible system in the future, you should be able to take the archival packages and you should be able to just transfer them forward into the new software. And that's an important point when it comes to things like product model data. We're dealing here with designs which are designed, needed to be archived for the service lifetime of a product. And the people within LOTAR that I've been working with are dealing mainly with aerospace. They're dealing with aircraft. And commercial aircraft will have a long lifetime, and one within which the archival data needs to be preserved, and it needs to be provable that that is authentic within that period. And that period most likely will actually be longer than the software which produced the models, and it will be longer than the archive software which is used to archive it. So mobility is extremely important. The CSIP also enables us to create a common base for development of tools. So further definitions such as the CITS, but also tools which we can use to actually produce packages and to validate them. So for example, there is a validator for the CSIP. And of course, you can use that to validate not just generic packages, but you can also use it to validate CITS packages. So a 3DPM or an eHealth1 package can be validated using the generic CSIP validator. The CSIP proposes a specific XML-based implementation, which will be conformant to the validation procedures. And through this, we hope to achieve this level of interoperability between information packages. And so institutions can adopt the specifications, they can adopt software tools and platforms which conform to it, and they can achieve a level of interoperability and mobility which cannot be achieved very simply without having this very secure basis. And part of that basis is the use of standards. So the CSIP relies on existing international standards, as you would expect. So in addition to OIS, we use XML extensively. We have adopted the METS, the Metadata Encoding and Transmission Standard, and PREMIS for the recording of package and preservation metadata. And of course, the number of standards used increases. So each CITS tends to be based on, or can be based on, existing standards. So the CIARD database standard is based on the CIARD standard itself. The ERMS standard is based on MOREC 2010. The eHealth1 standard strongly recommends standards such as HL7 FHIR, which is a patient medical record information standard. And this one, the 3DPM, is based on LOTAR, the existing long-term archiving and retrieval standard for 3D product model data. Within each standard, and the CSIP included, tend to have general principles. So they set out the general principles for conformance. And so, for example, within the CSIP, the first and probably the most important principle is that the CSIP must be able to include any data or metadata, so regardless of its type or format. So again, you could build a package around the CSIP for a product model data, and you could make that conformant to the CSIP. But it is useful to actually follow the requirements of the CITS in addition to that, because that allows for additional requirements which are deemed to be important. And as I'll show you in the specific example we have of 3DPM, the requirements lean very heavily on the requirements which are required by LOTAR. In addition to the principles, within each specification, we have specific requirements. So within the CSIP, for example, there is a specific requirement to use METS, the Metadata Encoding and Transmission Standard, and for those METS files to actually follow the official METS schema. And then there is an extension schema which is published by CSIP, published by the DILCIS Board, and of course is available on the DILCIS Board website and is available in GitHub. In addition to the general principles and the specific requirements, we have a package structure. Now, the package structure is interesting in that, again, going back to OAIS, one of the fundamental requirements of OAIS is that information should be put into packages, namely the submission, the archival, and the dissemination package. And there is a good reason for this, in that if you can put information together with all of its associated metadata into a self-describing package, then that package can then be most easily preserved for the long term. And if is then taken by somebody in the future, and is the best way of actually providing them with all the information they need when they unpack it to actually understand the contents. So, for example, in a e-archiving package, and we actually include a folder where you can put schemas. And so we recommend that along with the package, which should be self-describing, that all of the schemas required and all the associated documentation required is actually included in the package itself. So the general principle being that all of the information, not just the data, but the metadata, the schemas, and the associated documentations is included in this package structure. It is recommended, but not mandated, that that package should be physical, i.e. a folder structure. And that's the way that most of these are implemented today. Within the structure, you can see that we have various subfolders below the main package folder. We have the METS file. We have an area for metadata, so it's very easy to locate the essential package metadata, and that is split down into both descriptive and preservation. We have a folder for schemas, as described, and for associated package documentation. And lastly, and one of the bits I want to actually just delve into is this use of representations. So there is a master folder called representations, and you can see that within this, we actually have two representations within this package, but they can be anything from one to many. And the representation contains the core data for the package. And within it, we also have its own METS file, its own metadata file, and continues, so it actually maps the main package structure. And a representation contains all of the information related to a particular execution or form of a particular intellectual entity. So an archival package, according to OAIS, should be contain a single intellectual entity. And within our package, the representation will contain a particular manifestation of that in terms of its technical form. So if we look at 3DPM, there is likely to be a representation for an output from the original system, say a computer-aided design system which generated that information, the associated documentation, the associated authentication information that goes with it, and that will form a particular representation. One of the recommendations for 3DPM is that we then have an open format representation. So most likely a step derivation of that original CAD file. And again, that representation will have its own authentication information in its own metadata. So the representation is very important, and that's a very key characteristic of E-ARK, is this recommendation to use different representations within the package. There's also a recommendation to use PREMIS. So it is not a mandatory requirement to have a PREMIS file in each package, but it is strongly recommended. And certainly if you are going to put preservation metadata, any technical metadata or rights metadata, then it's recommended that is put in PREMIS form and that you actually use the PREMIS data dictionary to do that. And we're coming back to that with regard to specifically the role of PREMIS within 3DPM. So moving onward and talk about specifically the new 3D product model CITS or 3DPM. So this is intended to be part of a family of 3D specifications. So this is a bit of a departure from where we are today with the CITS, is that they are all fairly niche and separate in that they're dealing with different domains and different data types. But within the 3D arena, which is a very wide area covering different use cases, different domains, different data types, there is some commonality. So we actually are looking at a family of 3D specifications concerned with different manifestations, if you like, of 3D data. So the 3D product model is the first, and the first probably for good reason in that it did have a basis to work on, which is the existing LOTAR standard. But we are already working within the 3D working group on a CITS for 3D cultural heritage models. So that's in development, and in fact it is in draft. And we would hope to have the 3D specification actually available for review sometime this year. So that should get open for review and published probably in this calendar year. What we also hope to do is we'd hope to start on the third member of the family, which is on 3D building information models. So that's following existing BIM standards, and we'll be concerned with construction and architecture. So that is planned. So 3DPM, what does it contain? Well, it's similar to the CSIP, the document, the specification document sets out its purpose and its scope, the general principles, which are in addition to those of the CSIP, the use cases that it is intended to serve, and this is important in the CITS documents, is to understand actually where the CITS is intended to be applied and where it is not. And then we have the most important bit, which is the specific implementation requirements and recommendations. And those are around the package structure, as you've seen, so an extension to the requirements of the CSIP. A new area, it talks about authentication and digital signatures. And then it talks about preservation metadata and rights metadata and the use of METs and PREMIS. So purpose. The specification is designed to be used for the transfer of 3D product data to archives as well as for records exchange. So we'd expect this to provide interoperable packages so we can transfer information to an archive which contains product model data, but we can also use it for exchange. So it should be understandable and usable by any user, regardless of which systems they're using. So it's reliant very much on open formats and reliant on international standards. The scope is 3D product data. So, mainly probably computer-aided design data, but I include the broader definition of product model data and talk a bit more about that in reference to the STEP standard. As I've described, it builds on LOTAR, that's the long-term archiving and of digital technical product information, which is published as EN 9300. Important point here is that conformance to LOTAR is not mandatory within the e-archiving CITS. So you can have a CITS package which is valid and conformant, but it doesn't necessarily conform absolutely, or the submitter has not been audited to EN 9300. We are taking a requirement so that if you are trying to achieve conformance to 9300, It can be achieved through the use of the 3DPM packages, but use of the 3DPM packages is not provisional on the conformance to LOTAR. LOTAR is very much built on ISO 10303, so it came out of the same organization. STEP was developed by PDES, and LOTAR has sort of sprung board from that and is a ENAS standard for the archiving of product model data, and it very heavily references the work within 10303. 10303, I think, is one of the biggest ISO standards that exists. It is massive and it's expanding all the time. And ISO 10303 divides down into different parts, some of those parts being application protocols which deal with very specific different data or information types. So we talked here about computer-aided design, and there are specific application protocols for CAD-generated information, but also there's parts or application protocols for STEP which actually deal with things like wiring harnesses and electronic and electrical systems design. So there's a lot of detail in there, and the work within LOTAR works very much layered on the work of the STEP standard. So use cases, three main use cases. We've got the submission of product model data from engineering to an organizational archive. Interesting to note that the main use case for product model data archiving is actually in a commercial or public sector environment in the during the design of a product. So we're actually talking about archiving data at the point of its creation. So when for example, aircraft are being designed, the information when the design is finalized and frozen, the information will be submitted into a organizational archive, which could well be a private commercial archive. The products, aircraft as an example, have very long lifetimes. So a frequent event is the merger of companies during the product life cycle, and so the consolidation of archives. So quite often either companies will reorganize, so the different divisions of large companies reorganize and archives will be consolidated, or archives will be consolidated through acquisition and merger. And you can see how the importance here of the interoperable package format becomes very important, because you don't want to create a lot of difficulty in trying to consolidate these archives by having very disparate systems and different standards. And lastly, of course, the dissemination of archival data, preserving the integrity and authenticity. And this is an interesting one because, again, within this domain, the main objectives of dissemination are either to actually get knowledge about older products. So somebody, when they're designing a new product, may want to go back and look at the design for a previous product. But one of the big drivers is that of legal requirements. So product designs are archived for reason of future litigation or law process. So particularly, again, if you regard to aircraft construction, it's important that there is proven authentic information about the design of the aircraft available should there be any problems in the future. So principles within 3DPM. So there are two. The first one we talked about is LOTAR conformance. And it's important, although that we are borrowing and layering ourselves on LOTAR, that we do not conflict with any of the requirements in LOTAR. So 3DPM does not provide any requirements which will stop you from actually achieving LOTAR conformance. So requirements for the package and for package metadata, so metadata requirements and package requirements in LOTAR become requirements in CITS 3DPM. So we are allowing conformance, so trying to accommodate all the requirements that LOTAR has. And the interesting thing is that LOTAR as a standard is concerned mainly with the production of the product model data, the accompanying metadata to enable the long-term archiving. It's not concerned with the specifics of package design, which we're involved in e-archiving. So they're almost a perfect fit. And you can create this symbiotic relationship whereby that we can have a package which allows LOTAR conformance, but it's not actually necessary that you are conformant to create a CITS 3DPM package. The scope of the CSIP, most importantly, is not altered. So LOTAR requirements exist and standalone, which there is no implication within the archiving specification, and the scope of the CSIP is altered. So it's still only concerned with the actual package itself and the requirements to create an interoperable packages. It's not concerned with the other things which LOTAR is concerned about, mainly around process and management procedures involved in producing the archival data. Secondly, we build on the CSIP recommendation for PREMIS, is that we should use PREMIS to record technical metadata. And this is one of the important things that's come out of the LOTAR basis, and that is the requirements of LOTAR, such as digital signature events, verification and validation events, can be recorded within PREMIS and thus meet the recommendations of the archiving specifications. So let's look at the specific requirements. A bit of a busy slide, sorry about this, but this is the package structure for 3DPM. And actually, if you look down to the right under documentation, the only real change, the addition to this, is the addition of subfolders within the documentation folder, and specifically one called authentication. And that is mirrored within the representations. There is also an authentication subfolder. And within that, we have documents related to the authentication procedures. So at a package level, namely validation properties, data quality rules, and signature validation documents. And then at the representation level, we've got the outputs of the authentication events. So we've got the validation properties, a validation report, and we have a verification report. So this is a place to specifically put documentation which supports the events which have occurred for the authentication of the model, and those events would also appear as events within the PREMIS files. So core data. LOTAR actually defines what it means as the core model, the core data model, and it's being the essential minimum amount of data which is required to preserve the design intent for a given purpose. So the domain-specific parts of LOTAR identify a purpose or set of purposes through appropriate use cases, and therefore the core model which is required to support the business case. So simply put, there are a number of domain parts within LOTAR which talk about specific data types. So we may have the core computer-aided design model, we may have wiring harnesses, we may have test systems, etc., within the various domain parts. Those domain parts actually then reference quite commonly, typically reference the corresponding application protocols within ISO 10303. So the STEP standard will describe very fundamentally what the data specification is. LOTAR will actually describe the conditions for its production and for the associated metadata, the minimum amount of data, and then that can then roll forward into a package which is designed according to the CITS. So authentication. LOTAR specifically requires that product data models are validated and verified, so that there is an amount of validation information, and this actually concerns the consistency of the data content, the core data model, between representations. So we actually showed there earlier that the CITS requires at least one representation and should probably have at least two, so a proprietary and an open representation of the core model. And the validation information will set out the rules as to how you actually ensure that each representation is a true reflection of the original design, and then will actually contain reports on each validation event. So there will be processes to go through to actually run the validation and produce a report against the rules data, which actually proves or disproves as to is this a true reflection of the primary design. Likewise, verification actually concerns the quality of the data within tolerances. So data quality rules will set out actually how precise and accurate the model should be, and the verification procedures will actually test that data within tolerances. So we have rules data and we have verification events and the output of that in verification reports. Lastly, the requirement in LOTAR to actually have a digital signature on transfer to archive, which is commonly a digital signature. Just to describe that in more detail, so the requirement is that the design is signed off by the engineer on submission. So it is verified as a true reflection of the design at the point where it's put into an archive. And the evidence is required to be included of that signature. It is not a requirement within LOTAR that that signature is re-authenticated over time. So we don't have the problem of having to re-authenticate with external providers. It's just necessary that there's evidence that it was actually signed at the point where the information was put into the archive. So we can represent this information in 3DPM by PREMIS events, and we can use PREMIS for recording signatures. We can use PREMIS for recording events related to validation and verification. And within the document folders, we can include the validation properties rules data and the verification of data quality rules at a package level. And then we can include the output of the events, that's the validation properties and the verification results reports within the document folders within the representations. So the specification is on GitHub, and in the repository there, you can actually pick up the specification. There is an associated guideline, so that actually provides more contextual information and help in terms of the implementation. There are XML METS profiles for both root and representation to help you with production of your own packages or writing of software. And we have one example package, which is the image that you've seen a few times in the presentation, which is it's called Mars Rover. It's clearly not. It looks like it's made of Meccano. It's an example CAD file which was produced by ProStep for use in different exercises. Sadly, though, even though it's only of a model, it's still a very large file, and I've had to truncate it. So we can provide the full package with the full CAD file, but the one in GitHub, which I think has a 25 megabyte limit, which really isn't big enough for any 3D models. So unfortunately, with the examples, we have to truncate the files. So next steps. As I described, you can actually submit issues via GitHub, and I'd be very, very grateful for that. Those will be addressed. So we bring those up at the DILCIS Board meetings, and I will be addressing those issues, feeding back, and putting changes into the specification as necessary. So I am building a 1.0.1, and I've no doubt there is more to do to actually build into that. And we'll look at when it is necessary to actually publish that. There's nothing drastic at the moment which requires immediate publication. So we'll keep that open until we feel we need to publish. Interesting work going on within LOTAR. I'm actually a member of the core working group within LOTAR now. We're going through a process there of revision of the core parts of the specification from what it was, which was a very free text style document, which was extremely difficult to actually execute particularly in terms of certification and audit, to a much more table-like structure. So there are now going to be much more specific requirement statements within LOTAR. So that's going to be very useful, and of course it will allow me to go back and review the LOTAR standard and how that reflects within 3DPM. There's also going to be a new core part, which is part 21, developed hopefully this year, which is around metadata. So this will be roll-up metadata requirements from the domain parts, and it'll overlay that with broad requirements for the core parts and make specific requirements or recommendations for included metadata. And that's going to be very interesting from the point of view of the how that is accommodated, if there's anything additional that needs to be accommodated or recommendations made within the CITS. So we'll be following that very closely. And lastly, we talked about the family of specifications, and one of the common themes which comes out of the 3D work is that very often the specification, let's say a specific specification for producing an AIP for a part of a much larger product, is often part of a larger structure. So that's easy to see, for example, within a product design and with an aircraft, which is extremely complex design, is that you will need AIPs for sub-assemblies, maybe for components, and then for assemblies and for the whole design. And rather than being able to create a design and put it into a single archival package, an archival collection will consist of many, many AIPs related to each other. And similarly, within construction, where if you start talking about construction projects rather than just BIM models, there is a lot of associated information, such as project files, materials lists, material specifications, which all come together to form a whole in terms of a construction project. And within heritage, which we've been talking about recently, the 3D heritage model alone is often associated with a lot of contextual information about the history of the object, its relationship to other objects, and a lot of information termed paradata within those of how the model was actually created. So the processes and decisions that went through to the creation of the model. And a lot of that information, again, will not be able to be included within a single package. So we need some way of creating hierarchies of AIPs, which are can be seen as a structure, and we can understand the structure and reference the other parts of the structure within them. So that's a piece of work which is going to be ongoing. That may be reflected within the AIP specification. The AIP specification does today talk about split AIPs and flat structures, but we need to start looking at hierarchical structures. And I've also started looking at, for example, use of ontologies like records and contexts, or there's one within the heritage domain called the CRM, where we can now start to use more linked data or RDF ontologies to actually provide a structure between AIPs, not just describe the data within the AIP. And of course, I'd really love more examples. So in addition to the Mars rover example, it'd be fantastic if we could actually gradually build our number of examples within the repository. And that brings us, I think, in fairly good time, Jamie, to questions.